Today I'm going to show you how to lay out the centered square to round transition. We're going to use triangulation as a method of pattern development. Triangulation is using two known points to locate an unknown point. And I am the draft doctor. Our shop ticket today is a 10 by 8 to 6-inch round squared around with a 2-inch collar, and it has to finish at 10 inches. Now, this fitting has a slip and drive connection on the transverse connector, so we're going to have to interpret that. If I want my finish to be 10 inches, then I must interpret the S and drive connection. And with an S and drive connection, I have a material line, a finish line, and a working line. Now, the distance between my finish line and my working line is a 1/2 inch. The distance between my working line and my material line is 1 inch. So, in short, this means that I'm going to lay this fitting out over 9.5 inches. I'm going to add 1 inch to my S and drive connection, and that will give me a finish line of 10 inches. It's important we understand our transverse connectors in the sheet metal industry. It is everything that determines the length and the finish of our fittings. Now, we are going to lay this fitting out from a plan view. So the first thing I need to do is create a rectangle that is 10 inches by 8 inches. So let's just start with a quadrant here. I'll be doing this on the 3/8 scale. So once again with the 3/8 scale, red flag, red flag. Watch out for the 10s. There's the 10 on my 3/8 scale. This other 10 is the 10 on the 3/4 scale. So there's 10 inches. Here is my 8 inches. And let's just draw that in now. Here's my 8-inch side. I'll darken these all in. All triangulation starts with the production of an accurate working drawing, and that's what we're building right now. So there's my 10 by 8. I'm going to mark the seam on this 10 by 8, which would be at the 4. There's the center that way. I'm also going to mark the center this way on this center line, and that will mark the center now of my 6-inch round. If this is a plan view, I would be looking into the 6-inch round and seeing the 10-inch round at the other end. Now, 6-inch round would require a 3-inch radius. So I'm just going to set my dividers at 3 inches on my 3/8 scale right there. And let's just draw this in now. And here now we will have an accurate working drawing of my square round. I'm looking straight down at it. You might have guessed triangulation is working with triangles. In other words, we are going to build triangles all around the surface of this fitting. And in order to do that, I need to locate the element lines, or where my 1/12 spacing would land on the 6-inch round. Now, in reality, this fitting I'm making is symmetrical. Each quadrant is exactly the same. I could actually lay this out using a quarter of a plan view. But that would mean I would be assuming that you've done this before and understand it completely. So this point, I'm going to learn from here. This point, I'm going to figure it from here. I'll triangulate it from there. And what you're seeing now is a pretty nice view of a squared around from the top. And these are the triangles that we're going to use to build this fitting. What we're going to do is lay out a half pattern. Here's my seam, and here's a seam. Now I'm going to number this. I'm going to start with 1 at the top, 2, 3, 4, 5, 6, and 7. Now, 1/2 is going to be exactly the same as the other half, so what we'll do is lay out 1/2, and then we'll put a shop instruction stating that we actually need 2. So, we have our top numbered. We're going to now number our bottom. Well, this is the seam, and I'm going to call this corner A, this corner B. I'm going to come down here and call this C and D. Now, although we're not going to use the C and D, I will explain this to you now. If this fitting ever comes off center and I have to lay out both sides, if I lay out AB the way it is, then the pattern will drop down this way and I will get an inside pattern. If I exchange my CD and flip-flop them, then I can lay it down this way and also get an inside pattern. It'll make more sense when we do the off-centered squared around, which is a coming video. Now, in order for me to start, I have to triangulate 2 known points to locate an unknown point. Well, I know that A and B are 10 inches apart. So let's just take this line, we'll extend it a little bit, and on our 3/8 scale, we'll mark A and B. So this now would be A, and this now would be B. So here's my line AB. Now, a point common to A and B would be point 4. Now, A, 4, and B. I can find 4 if I only knew how long A4 was and how long B4 was. I'm going to find that out by building what they call a true length triangle. So here's what a true length triangle looks like. Very simply, I'm just going to create one leg and another leg. I'll call this my true length triangle. And I'm going to mark the height of my fitting. My working height, we figured to be 9.5 inches, right down here at the bottom, 9.5 inches, because we want it to finish at 10. So, I'm going to mark 9.5 inches for the height on my true length triangle. There's a half, and 9 is this funky little 10 right here, so there is my height. And I'm just going to put a little mark on there. There's my 9.5 inches height. 9.5 inches high. And here's how triangulation works. This is where it gets fun. If I take the length of A to 4, and I plot it on the bottom leg of my true length triangle, there's A4, And I should document A4. So, my height, my plan length of A4, what we will have now, if I take the hypotenuse of that triangle, I will now have the true length of A4. So from A, 4 should be on this arc somewhere. Where? Well, we're going to find that out by finding B. Now, B4 has a plan length there, and it happens to be the exact same as A4. So let's tag that A4 and B4 because we are on center and everything is symmetrical. So my B4 now is this long. A4, B4. So from B, there's B4. I have just located point 4. Now what? Well, I have two known points, A4. I have two more known points, B4. I guess my next step would be to find 5 and 3. I can use A4 to find 3. I can use B4 to find 5. Now, in order to do that, we have to figure out a 1/12 spacing. In other words, I need to know the distance between 7, 6, 6, 5, 5, 4, and so on throughout this round side. I could take it off of my profile here, or off my plan view, but that's really not an accurate thing for me to do. So what we are going to do is we have a stretch out for a small end of 6-inch collar, 6 times pi, and then we subtracted a 1/4 inch to get our small end, and we got 18.5996. Now, if I take that 18.5996, 18.5996, and I divide it by 4, I get 18.5996, and I divide 4. I get 4.6499. 4.6499. And I'm going to subtract 4 and then times 16, and I get 4.6499. 6499 times 16. I get 5/8. So 1/4 of the 6-inch circumference is equal to 4 and 5/8. Okay, here's how easy this will be. We're going to make a line. I'm going to measure it, 4 and 5/8. Here's my 4. Here's my 5/8. We'll set up a perpendicular through those lines. And now what I have is 1/4 of my 6-inch small end circumference. If I divide that into 3 equal spots, and then I would have a 1/12 spacing. So here I have from 0 to 6, and I'm just going to mark 4 and 2, and that has divided that oblique line into 3 spaces. But now if I just transfer them to my baseline, I now have a 1/12 space that represents my circumference. So here's what we're going to do now. Set up our small bow compass at my 1/12 space, and now we're ready to triangulate. I know that from 4, somewhere on this arc and on this arc is 3 and 5. So let's check it out. A to 3 is this long, and it is not a true length. We will find its true length by bringing it to our true length triangle. And I want to tag that A3 now. A3, it's also B3 because we are symmetrical. My true length of A3 and B3 now is here. So from A and B, from B I'm going to intersect this arc here. There is 0.5, and from A I'm going to intersect this arc here, and there's 0.3. So here we have 3, 4, and 5. Next, I now have B and 5. I can use B and 5 to find 6. Well, from 5, 6 is somewhere on this arc. From 3, 2 is somewhere on this arc. How do I find it? Well, from B, I'm looking for 6. Here now is my B6. Is it a true length? No, it's not. Here now is my length B6. I'm going to tag that. B6, it's also A2. And here is the true length. All right. There is the true length now of B6 and A2. So from A, there is 0.2. From B, there's 0.6. Let's document that. 2, 6. And we're going to repeat the process. Back to my 1/12 spacing. From 6, somewhere on this arc will be 0.7. From 2, somewhere on this arc will be 0.1. Well, A1 is this length right here. It's also B7. Here's A1 and B7. A1, B7. It is of the utmost importance that you document when you're doing layout in sheet metal, because if you ever make a mistake, you have to be able to come back and find something. A1 and B7. A1, B7. If you don't document stuff and you make a mistake, your fitting is done. If you have everything documented, there's a lot of chances that you may find the mistake and correct it without having scrap or garbage. So here's what we have. We have A and B, and we have 1 through 7 laid out. Our next step is to find this seam. Well, it seems to me that if I take my length of A to S, that would be a true length. So from A to S, that is a true length. It is perpendicular to my plane of vision. From B, S is somewhere on this arc. From A, S is somewhere on this arc. We're doing the same thing. We're just triangulating from the top to the bottom now. Next, I have to look at my seam. Well, from 1 to S has a plan view of this long. Is it a true length? No. So here now is my seam length plan. S1, S7. This is also an S. Plan, height, true length. We should always ask ourselves, anytime we're taking a dimension off of our working drawing, is this a true length? Think about it. Now, from 1 I now find my seam. From 7, I now find my seam. And we can connect the dots. From 1, there's my seam. From 7, there's my seam. From seam to B is this distance. From A to my seam is this distance. Now, because this is a centered fitting, here's my double check. These angles should be 90 degrees. And lo and behold, using my trusty French curve, I'm going to just draw in my round. I kind of missed that a little bit, but that's okay. I would also have to add in a 1/4 inch here. That will accommodate my 1/4 lap and spot that is going to go onto my collar. Next thing I have to do is accommodate my S and drive connection at the bottom. Now, from A to B, I simply have to add an inch. There would be my material line. Here's the 1/2 inch that comes to my finish line. And I'm going to use my 45-degree triangle now just to notch that S. You'll see plasma machines will always notch their S and drive connections at a 45. This is to help the installer make his connection. It's a variance from the old V-notch that we used to use that would always leave a hole right in this spot where my pencil is now. We don't have that issue anymore. I need to add my S and drive connection to the wings here. So what I have to do is come off of that line at 90 degrees from here. .90 degrees there. My tools are getting in the way. And 90. I will take that, make it an inch. On my 1/2 inch scale. My 1/2 inch scale. And this would be a nice little 45-degree notch here. There will be no notch on the side that's going to have my lap and spot. Anytime you're not sure about notching, make sure you angle your notch 90 degrees to your finish line. I'm always going to notch 90 degrees to my line, to my working line, to my working line, to my working line. And there I have my squared round. Now, this is how those triangles look on the pattern now. Now, shop instructions. Well, here's what we have. We have a 10 by 8 with a S and drive connection. Here I have a 1/2. No, I don't. I'm not going to mark that yet. 1/4 inch lapping spot here. Here we have to, this has to be rolled 90 degrees. This has to be formed 90 degrees, and we can step break that in the brake. Here we have 8 by 10 drive and S. Now, one of two required. I don't have to say mirrored because they're symmetrical, and I'm going to put a note 1/2 inch lap and spot on piece 2. If I put my lap and spot on my original layout, it's kind of tough to subtract it from the one after I trace it. If I take this one, cut it out, trace it, then add my seams for piece 2, everything is good. And that is a triangulated squared around. Once again, make sure you interpret your shop ticket and get the proper working length. If I don't have the proper working length, this fitting is going to be either too long or too short, and I'm probably going to hear about it. Have a great day. I am the Draft Doctor. Subscribe, click like, send me a message, anything you want to see, I will lay it out for you.